All right, we already factored trinomials in the form x squared plus bx plus c. Today we're going to factor in the form ax squared plus bx plus c and perfect square trinomials. So now you will have a number in front of that quadratic term. So I know I've got this when I can factor trinomials in the form of ax squared plus bx plus c, where a doesn't equal 1. Factor out a GCF before factoring the trinomial of the form ax squared plus bx plus c, and factor perfect square trinomials. So key vocabulary: a perfect square trinomial is a trinomial that is a square of a binomial. For example, if you have x plus 3 squared, you would multiply it out and get x squared plus 6x plus 9. That answer, that product, is a perfect square trinomial. So today we're going to be taking those perfect square trinomials and factoring them back into the form that you see here, x plus 3 squared. So we're going backwards. So some methods to factor trinomials in the form ax squared plus bx plus c are guess and check, factor by grouping, the box method, and then slide and divide. Today, we're going to be using guess and check and factor by grouping. So this is one factoring example I wanted to show you. Okay, so I want to show you both ways. So I'm going to show you guess and check first. So you would say, okay, what times what is 5x squared? 5x times x. What times what is 10? 2 and 5. And you know both of your signs have to be positive. But how do I get this 27 in the middle? Okay, so if you do 2 times x, you would get 2x. And if you multiply 5x times 5, you would get 25x. And if you add these together, you would get that middle number, which is 27x. So that is how you do guess and check. All right, to factor by grouping, which a lot of people find it takes longer, but it's actually easier in the long run. Okay, so I'm going to write this again: 5x squared plus 27x plus 10. You multiply the 5 and the 10. Okay, so you say 50. So what are factors of 50? That would give you 27, 25, and 2. So you go ahead and you replace the 27 with the 25x and a 2x. Let me move this a little bit. Hold on. It's in the way. There we go. Plus 10. So you see, I just replaced the 27 with the 25 and 2. Now you split it in half, how we did the factor by grouping before. So what can I factor out of the front? A 5x. What am I left with? An x plus 5. What can I factor out of the back half? A positive 2. What am I left with? An x plus 5. What did both of those have in common? An x plus 5. What don't they have in common? 5x plus 2. So you already know like starting here, factor by grouping. So the only new part today is we're multiplying this first and last number to get 50. And then you say, okay, what are factors of 50 that would add together to get 27? And then you substitute it. All right, so on example 1A, I'm going to do this using guess and check, because if I multiply the 21 and the 10, I'd be dealing with 210, which I really don't want to have to do that. Okay, so I'm going to say, what numbers multiply together to give me 21x squared? 7x and 3x. Okay, what are numbers that multiply together to give me 10? Well, 5 and 2. So I'm going to try this. And I know both of my signs have to be negative because I'm multiplying to get a positive, but that middle number is a negative. So let's see if this works. I'm going to multiply these together and I would get negative 6x. Multiply these together and I get negative 35x. And if I add these together, I get that negative 41x in the middle. So this is my answer. And theirs is in a different order, but that's fine. Okay. 1B. All right, let's try this. So This is a good example where factor by grouping is actually helpful. Okay, so let's multiply the 3 and the 6, and I would get 18. So what are factors of 18 would give me 7? Well, you're going to think 9 and 2, but remember this is a positive 18. And for this to give me a negative 7, that 9 would have to be negative, which would not give me a positive 18. Therefore, it's a prime factor, it's a prime polynomial and will not factor. So you just put not factorable or prime. So like in your answers, if it is that case, you just write prime. Okay, you go ahead and try this. Okay, and you should have gotten this for your answers. So you'll see that I did 1C by guess and check, and I did D by factor by grouping. All right, 2A. All right, so we have to factor this. Now, what is the first step in every single factoring problem? You factor out the greatest common factor, which in this case is 2y squared. So if I factor out a 2y squared, I am left with 3x squared minus 1x minus 30. Okay, now I'm going to factor this using guess and check. So what times what is 3x squared? 3x and x. What times what is 30? We know that it's 10 and 3, right? So I'm going to put a 3 here and a 10 here, because let's check it and see. You can't forget that. If you're doing guess and check, you can't forget the check part. Okay, so I need to get a -1, right? So this will give me a negative 10x. This will give me a positive 9. So if I combine those, I get that -1x that I need in the middle. So this is my final answer. Okay, 2b, what do I need to do first? I need to factor out the greatest common factor, which in this case would be 2m, and I'm left with 2m squared plus m minus 3. Okay, now I'm going to factor. So what times what would give me 2m squared? 2m and m. What times what would give me 3? Well, it would be 3 and 1. And now let's check just to make sure I'm getting the right answer. So this would be 3m, and this would be a -2m. So those together would give me a positive 1m that I need. So this is my final answer. Okay, one more. So what is the greatest common factor? Can I do anything? No, those don't have anything in common. Okay, so let's try something else. All right. So what times what would give me 6m squared? 3m and 2m. What times what would give me -5n squared? Well, I know I can write my n squared to get that kind of out of the way, where I just have to think about my 5s. So if I put a 5 here and leave this as a 1, this as a plus, and this as a minus, let me check it, make sure. I would get 10mn, and for this one, I would get a -3mn. Together, it gives me a positive 7mn. So that is my final answer. Now, I want to show you how to do the same exact problem using the factor by grouping, because some of you may think this is kind of hard, because for 6, I could actually use 6 and 1 or 3 and 2. I just knew which one to use. Okay, so let me show you how to do it if you don't know. First, before you even start out, let's take care of the variables. So you know you're going to have an m here and an m here and an n here and an n here. Now we can just worry about the numbers. Okay, so 6 times -5 is -30. So what are factors of -30 that would give you a positive 7? A 10 and a -3, right? So I can rewrite this 6m squared plus 10m n, because I'm using this, right? Minus 3mn minus 5n squared. So I'm just substituting the 10mn minus 3mn for the 7mn. All right, now I'm going to break it in half and factor. So what can I factor out of the front? A 2m. And I'm left with 3m plus 5n. Okay, in the back, what can I factor out? I can factor out a negative n, and I'm left with 3m plus 5n. And so what do they have in common? 3m plus 5n. What don't they have in common? 2m minus n. Let's just check it and make sure. So this would give us a positive 10 and a negative 3, which is a positive 7. So 3m plus 5n and 2m minus 1n. Either way you do it, you can get it. And that's the correct answer. So either way you feel more comfortable, go for it. All right, here's one that I want you to do. Remember to factor out the negative one first. Pause it and try. And you should have gotten negative p plus 4 times 2p minus 3. Okay, so example 3, we're going to factor 25x squared plus 20x plus 4. This falls under the category of perfect square trinomials, but I'll show you why. What times what is 25x squared? 5x and 5x. What times what is 4? 2 and 2. We know both signs need to be positive. So let's check it and see if I can get it. So this gives me 10x, 10x, which would give me the 20x that I need for the middle. So this is correct. I can also write that, since it's the same binomial twice, I can write it 5x plus 2 squared. And if I can write my answer as a square, a sum of squares, then that means that I dealt with a perfect square trinomial to begin with. So in the last example, this says what I just said. We factored the polynomial 25x squared plus 20x plus 4. The result was 5x plus 2 squared, an example of a binomial squared. Any trinomial that factors into a single binomial squared is called a perfect square trinomial. That's a good note to take. So factoring perfect square trinomials. Go ahead and write that down. All right, so factor the polynomial 16x squared minus 8xy plus y squared. Okay, so let's ask ourselves, what times what is 16x squared? 4x and 4x. What times what is y squared? Y and y. We know both signs need to be negative. Now let's check. So I get negative 4xy, negative 4xy, which would give me that negative 8xy in the middle that I need. Since it's the same thing, I can write it as a difference of squares. And yes, you can multiply it back out and make sure it's right. Okay, pause this. I want you to do at least some of them. And the answers are right there. Let me move this so you can see. Go ahead and write those down. Pause the video. Okay, so I know I've got this one. I can factor trinomials in the form of ax squared plus bx plus c, where a does not equal 1. Factor out a GCF before factoring a trinomial in the form of ax squared plus bx plus c, and factor perfect square trinomials. Do you really understand? Explain how to determine whether 2x plus 5 times x minus 2 is the correct factorization of that. Is it the correct factorization? Why or why not? Since the first times multiply to give you 2x squared and the last times multiply to give you 10, you need to only check the sum of the products of the inner and outer terms. This factorization is not correct because 5x minus 4x would equal a positive x, not a negative x. Give an example of a perfect square trinomial and show its factorization. There you go.